Welcome back. My name is Kevin Tokoph on Catalyst University, and in this video we're going to discuss arachidonic acid and its metabolism. Now, arachidonic acid is a very interesting fatty acid. It's a polyunsaturated fatty acid, 20 carbons long, with 4 double bonds in it. In fact, we actually briefly talked about polyunsaturated fatty acids in the previous video. And we mentioned that generally, beta oxidation only occurs on 3 types of fatty acids: saturated, or those with 1 or 2 at the most double bonds. If you have cases like this where there's 3 or more double bonds, such as is the case in arachidonic acid, 4, beta oxidation generally does not occur on those. It could in theory, but it really does not seem to. Instead, these fatty acids, these polyunsaturated fatty acids, are converted into larger and more complicated fatty acids, normally by elongation and addition of more double bonds. Now, arachidonic acid is what we call an omega-6 fatty acid. That means it is pro-inflammatory. Now, arachidonic acid is pro-inflammatory. It itself is not inflammatory. If you stick arachidonic acid in a cell, that molecule by itself will not be inflammatory. Rather, it gets converted to other molecules called eicosanoids, and those are inflammatory. So pro-inflammatory means it can be converted to something that is inflammatory. So let's start here. Here's arachidonic acid. Now, this pathway going down is called the cyclooxygenase pathway. Cyclooxygenase is an enzyme that converts arachidonic acid into a prostaglandin, and the parent prostaglandin is PGH2. And in general, I'm not going to go into a lot of detail here, but you can see that PGH2, the parent prostaglandin, can be converted into a lot of other different kinds of prostaglandins. You see actually 5 right here. I will say out of these 5, there is one exception in being inflammatory. PGI2 is actually an anti-inflammatory. It is actually also called prostacyclin, and normally it plays a role in preventing platelets from aggregating during normal blood physiology without tissue injury. Okay? Also, PGH2 can be converted into the parent thromboxane, TXA2, by thromboxane synthase. Okay? That's the COX pathway, or the cyclooxygenase pathway. Arachidonic acid can also go through the lipoxygenase pathway, or LOXes, in which arachidonic acid is converted into different leukotrienes. That is the second class, or I should say third class of eicosanoids, the first 2 being prostaglandins and thromboxanes. And you can also see there's a lot of different leukotrienes. We're not going to go into all of that, but you should at least understand those are the 3 primary classes of eicosanoids. But those are not by any means the only ones. There's also a couple other pathways. Here's one, the P450 pathway. And generally what happens, and you can see it better on here, is you can actually have hydroxylation of arachidonic acid. Those give you hydroxy fatty acids. And you can also have arachidonic acid epoxidated. That's going to give what are called epoxy icosahexaenoic acids, sometimes called epoxy eicosanoids. Okay? So again, these 3, leukotrienes, thromboxanes, and prostaglandins, are by no means the only ones, but in general, you should associate eicosanoids with one thing. They are inflammatory. They promote inflammation. Again, prostacyclin, PGI2 is an exception, but arachidonic acid, pro-inflammatory, and eicosanoids are inflammatory. Now, arachidonic acid metabolism is still vital. We would not live very long without inflammation. Inflammation is vital for fending off tissue injury, bacterial infection, wounds, all sorts of things like that. And some inflammation is actually necessary for physiological process, such as skeletal muscle hypertrophy, which is what your goal is when you go to the gym and do resistance training. In fact, you actually have arachidonic acid that gets released from membranes and metabolized into prostaglandins, and that's actually theorized as being part of why you have the pain associated with delayed onset muscle soreness. And arachidonic acid is necessary to start tissue redevelopment after you have these micro injuries after a bout of resistance training. In fact, there's been studies done that show that aspirin, which is an enzyme, or excuse me, a molecule that inhibits cyclooxygenase, thus prevent. In fact, there have been studies that show that aspirin, a drug that inhibits cyclooxygenase, which prevents the synthesis of prostaglandins, that using this drug after a bout of resistance training actually inhibits skeletal muscle growth. In fact, it's better just to man up and face the pain associated with muscle soreness than to take this drug. You will see better results with your muscle growth. But the main thing you need to associate with arachidonic acid, in addition to being pro-inflammatory, is your relative intake of omega-6 fatty acids versus omega-3s determines your inflammatory state. We can synthesize arachidonic acid inside of us. We can do that. We cannot synthesize omega-3 fatty acids. We must get through the diet, and they are therefore essential fatty acids. So, your relative intake of omega-6s and omega-3s determines your inflammatory state. If you get way too many omega-6s and not enough omega-3s, you are in a state of inflammation. If you get enough omega-3s, then you will not have as much inflammation. And while inflammation is good in some cases, we're talking about chronic inflammation, the likes of which heart disease, stroke, diabetes, a lot of Western diseases have been linked to inflammation. So, in retrospect, think of omega-3s versus omega-6s. We want to have a ratio where we increase our omega-3s relative to our omega-6s to avoid chronic inflammation and all sorts of comorbidities that go with that. And in fact, we are actually going to begin in another video talking about omega-3 fatty acids and their anti-inflammatory potential. One such example, which I really love talking about, is DHA, or docosahexaenoic acid. We'll start talking about this in the next video. But hopefully this gave you a little bit of intuition on arachidonic acid, omega-6s, and what they are for. Make sure to like this video and subscribe to the channel for future videos and notifications. Thank you.